Well, happy weekend. Here we go. We're going to do Chapter 9, Section 1, direct and inverse and joint variation. These are different ways of looking at equations, and since we're finishing up with solving, we're going to talk about what I can do with different equations. So, what's a variation? A variation has to do with two or more variables that are related to each other. When I deal with variations, I can either use direct or inverse. A direct variation are when variables move in the same direction. That means as one goes up, so does the other, and vice versa. What's an example of this? Well, the more I study, the better my grade is. The more I practice, the better I become. As one goes up, the other goes up. The more money I put into my savings account, the more money I have to invest. As one goes up, the other goes up. What's an example of this? Y equals 2x. Basic, almost like a linear equation. It is a linear equation, just a little different, where y-intercept is 0. What's an inverse variation? Well, this is when the variables move in the opposite direction. As one goes up, the other goes down. The faster I go, the less time it takes me. That's an inverse variation. The example of that is y equals 5 divided by x. Instead of multiplying, I'm going to divide by my x. Joint variation. Joint variation is when I do a combination. There are multiple variables involved. They can include both direct and or inverse. So I would need a third variable z. Z is equal to 5x divided by y. So it varies directly with x and inversely with y. Or I can have a separate equation like z is equal to 2x over, that's the same type, where it varies directly as one and inversely as the other, or 2xy, where it varies directly with both of the two other variables. That's what joint is. It's just putting other types of equations together. Okay, well, hold on. Let's go ahead and hide this. Example 1. Determine if the following situations show variables that vary directly, inversely, or neither. Well, let's see. A, time traveled and distance traveled. So the longer I travel as time goes higher, goes up, the distance goes up with it. So that means that has to be a direct variation. Okay? Well, let's try the next one. Songs uploaded and space left on the iPod. Well, as I increase the number of songs that I load, the space left on my iPod goes down, it diminishes. So then this, as one goes up, the other goes down, this has to be inverse variation. Okay, let's look at letter C. Time to eat 100 Chipotle burritos and the number of people eating Chipotle burritos. Well, as the time increases, the number of people decreases. Or, as the time it takes to decreases, the number of people eating has to increase. The more people eating, the less time it's going to take. The less people eating, the more time it's going to take. That's still an inverse relationship because it's going in an opposite direction. As one increases, the other decreases. Price of gasoline and number of gallons the tank holds. Well, what does the price have to do with the size of the tank? Nothing. So this is neither. They're not related to each other at all. Letter E, the last one. Number of days the vacation lasts and the amount of money spent on the vacation. Well, if I spend more days on the vacation, I'm more than likely going to spend more money. The longer the vacation, the more I have to spend. As one goes up, the other goes up. So this is going to be a direct variation. And that's kind of the gist of how I want to look at it. If one goes up, the other goes up. If one goes down, the other goes down. That's direct and inverse variation. So there are standard equations that go with each type of variation. If something varies directly, the equation is y equals k times x. K is called the constant of variation, and I have to find that k most of the time. What does my graph look like? Well, when I graph this, let's get this out of the way, I'm going to have a line that goes through 0, 0. That is direct variation. Here's another direct variation. Here's another direct variation. It's a straight line that goes through the origin every single time. That's what direct variation looks like. Okay? Well, what else do we have? Well, I can also talk about inverse variation. This is y equals k divided by x, where direct is y equals k times x. Y equals k divided by x. Again, this k is important. I have to find it. It is a constant. What does this look like on a graph? Well, when k is greater than 0, I'm going to get two branches. I'm going to get, that's one branch, and that's the other branch. This is y equals k divided by x when k is greater than 0. If I graph, what if k is less than, if k is less than 0, my graph is going to go from quadrant 1 and 3 to quadrant 2 and 4. When k is less than 0, I'm going to get the green graphs. So this is inverse variation. This is what the graphs look like. How would a problem look like? Let's look at this. Determine whether each equation shows direct, inverse, or no variation. If I go back for 1 second, direct variation is y equals k times x. Inverse variation is y equals k divided by x. Notice the similarity. It's y equals, and there's nothing added or subtracted afterwards. It's just k times x or k divided by x. So if I look at this, I want to make this y equals. So I'm going to multiply both sides by 3, and I get y equals 3x. Well, that has to be direct variation, because that matches y equals k times x. In this one, k is the constant of proportionality, is 3. Let's look at the next one. Y equals x plus 4. Well, this plus 4, neither of my direct variation or inverse variation has anything added or subtracted after the x. So this is neither. It doesn't match either pattern. Okay. Letter C, x, y equals 7. I want to solve this for y to decide if it's direct or inverse. So I divide by x. I get y is equal to 7 divided by x. Hey, that matches y equals k divided by x. So this has to be inverse variation. Letter D, y equals 1 divided by 5x. This particular problem, hold the phone. Well, this is kind of a bizarre type of thing to see, but I could always write my 1/5 as a decimal 0.2. So this would be 0.2 divided by x. This is still an inverse variation. An inverse variation. It still does the same thing. And lastly, letter E, this is already in y equals k divided by x. So this is also an inverse variation. All right. Well, what type of things are you going to see? Let's look at this. Example 3. Use the given information to write a variation question. Excuse me, variation equation. If x and y vary inversely and y equals 8, x equals 3, find y and x. Find y when x equals negative 6. Let's try that again. When x and y vary inversely and y equals 8, when x equals 3, find y when x equals negative 6. First thing I want to know is that x and y vary inversely. So y is equal to k divided by x. Step 1, I know the function. Step 2, I want to find k. So to find k, I'm going to plug in what I know. Y is 8, x is 3. So I'm going to say 8 is equal to k over 3. Multiply both sides by 3. So 24 is equal to k. So my inverse function is y is equal to 24 divided by x. They're inversely related. That's the function that relates them. Now that I have that function, I can use the second part to find y when x equals negative 6. So y is equal to 24 divided by negative 6. Ignore that bell. So y is equal to negative 4. That's the answer. That's the inverse function. Those are the two parts I need for this problem. So what do I need to do with these problems? Number 1, find the function. Number 2, find k. Number 3, find what's missing. Let's try letter B. If x and y vary inversely and y equals 6 when x equals 1.5, find y when x equals 9. Again, they vary inversely. So number 1, what's my function? Y equals k divided by x. Number 2, find k. Well, I know that y is 6 when x is 1.5. Multiply both sides by 1.5. So I'm going to get 9 is equal to k. So I know that y is equal to 9 divided by k. There's my function. I found what the equation looks like. I found k. I have my function. Now find what's missing. I want to find y when x equals 9. Wow, that's wrong. This is 9 over x. So x equals 9. So I am going to say that y is equal to 9 divided by 9. So y has to be 1. There's my y. There's my inverse function. So that's how things work when I'm talking about inversely. Let's talk about directly. If x and y vary directly, and y equals 12, when x equals negative 3, find y when x equals 25. So now I'm varying directly. So y is equal to k times x. That's first step. Second step, find k. Well, y is 12 when x is negative 3. Find k. Step 2, divide by negative 3. So k is equal to negative 4. So my function is y is equal to negative 4 times x. There's my direct variation function. Excellent. Now find what's missing. Find y when x equals 25. So y is equal to negative 4 times 25. So y is equal to negative 100. There's my function. I have my function. I have my answer. What y is when x is 25. Questions? Excellent. What other type of problem? I've talked about direct variation. I've talked about inverse variation. I haven't said much about joint variation. Joint variation, only what that means is I have more than one thing going on at a time. So let's look at letter D. If z varies directly with x and inversely with y, and z is 64 when x is 8 and y is 2, Find z when x is -6 and y is 10. Blech. Well, again, this is a joint variation because more than one thing is happening. But what's it saying? It's saying z varies directly, so that's k times x. And inversely, so that's k divided by y. It's only 1k. I don't have two k's in here. It's just going to be 1k. However, directly with x and inversely with y. So z equals kx divided by y. There's my function, joint variation. Now, I want this when z is 64. I want to find k when x is, when x is 8 and y is 2. Find z. Well, first I have to find k. So 64 is equal to, well, 8 divided by 2 is 4, so 4k. Divide by 4. So k is equal to 16. So my joint variation function is z is equal to 16 x divided by y. Now I'm going to find a new z given that x is -6, y is 10. So z is equal to -96 over 10. That's 60 plus 36. 96. So z is equal to -9.6. Double check that my math is right. 16 times 6 should be 96. Divide by 10, I get -9.6. So every time we do this, I have to start off with finding my variation, then finding k, and then finding what's missing. So what other type of things can I ask you? Well, I can show you a table. Let's look at this table. Determine whether each pair of variables varies directly, inversely, or neither. If they vary, give the constant of variation k. Okay, well, let's see what's happened. Let's see what's happening here. 6 to 5, well, x is going down. 5 to 3, x is going down. So as my variable x goes down, what's my y doing? Well, 7.2 to 6, well, y is going down. 6 to 3.6, y is going down. So it's varying directly. As x goes down, y goes down. So it should be y is equal to kx. Now I want to find x. Well, how do I do this? Well, I have x's and y's, x's and y's, x's and y's. So let's try this. I want to say 7.2 is equal to k times 6. Divide both sides by 6, and I get 1.2 is equal to k. Try it on the other one, just in case. 6 is equal to k times 5. Divide by 5. That's not 5. Divide by 5. Divide by 5. K is equal to 1.2. If I did this with the 3, 3.6 equals k times 3 divided by 3, I still get 1.2. So my k is 1.2. So my function for this is y is equal to 1.2 x. That's my direct variation function. And I checked a couple of these just to make sure. Let's look at number 2. Okay, number 2. As x goes up, 0 to 2, 2 to 4, y goes up, 0 to 2, 2 to 8. Okay, so let's see if I can find k. I'm saying it might be direct variation, so y equals k x. So plug in what I know. Eight is equal to k times 4 divided by 4. So k is equal to 2. But watch what else happens though. If I say 2 is equal to k times 2, divide by 2, I get k is equal to 1. Or if I say 0 is equal to k times 0, I get k is equal to 0. What the heck is happening here? It looks like it's direct variation. As x goes up, y goes up. But the k that I'm coming up with is not constant. Since the k I'm coming up with is not constant, this is neither. It doesn't match direct variation, and it definitely doesn't match inverse variation. So this is neither. Okay? Let's try number 3. So let's see. As x's 8 goes down to 2, 2 goes up to 4.8. Okay, well, 1.5 goes up to 6, 6 goes down to 2.5. What? Well, think about it. As x decreases, y increases. As x increases, y decreases. So this looks like this might be inverse variation, so I have to check it out. So, okay, let's check it out. Let's say that y is equal to k divided by x. Plug in what I know. 1.5 is equal to k divided by 8. So if I multiply both sides by 8, I'm going to go ahead and get 12 is equal to k. Does that work for everything? Well, let's see. We're saying also with that y, excuse me, 6 is equal to k divided by 2. Multiply both sides by 2, so k is equal to 12. Hey, that k works not only for the 8 1.5, but for the 2 6. Let's try the last one. What about 2.5 is equal to k divided by 4.8? Well, as I pause for station identification. So if I multiply both sides by 4.8, I get k is equal to 12. All my k's are the same. 12 is equal to k, 12 is equal to k, 12 is equal to k. So this is inverse variation, y equals 12 divided by x. Okay, last one, number 4. Again, I have to see, as 8 goes down to 1.6, 1 goes up to 0. I lied. 1 goes down to 0.2. As 1.6 goes up to 12, 0.2 goes up to 1.5. So as x goes down, y goes down. As x goes up, y goes up. That looks to me like it is direct variation. Y equals k divided by x. If I plug in my y's, 1 is equal to k times 8. So k is equal to 1/8. If I check this with the other two, and I say 0.2 is equal to k times 1.6, or if I say 1.5 is equal to k times 16, I still get the k to be 1/8, or 0.125. This still turns out to be direct variation, so y is equal to 0.125x. Or y is equal to 1/8 x. Either of these is my direct variation function. I can check it against all 3 of my points and I still come out with the same answer. So, direct variation, inverse variation. Last thing, write an equation for the given relationships. Y varies jointly with R and T. So if it says it varies jointly, it doesn't say one is direct or inverse, so we say that they're both direct. So Y varies jointly with R and T. Z varies inversely with M and jointly with X. So Z varies inversely with M and jointly with X. When it says jointly, you assume that's direct. Y varies directly with X with a constant of variation of K equals 3. So Y varies directly with X with a constant of variation of K equals 3. That's direct variation. And lastly, Y varies inversely with Z with a constant of variation of K equals negative 10. So Y varies inversely with Z. The constant of variation is negative 10. That's my notes. That's our problems. Hopefully it does make some sense to you. We'll talk more about this in class on Monday. Have a great rest of your weekend. Bye.